Is a video working through the Unit 2.1 review for matrices and transformations for your test on Monday. For this first part, we will be using the following matrices. So on number 1, we have -1/2 c. So that means we just have a scalar here, so we just take c and multiply it times -1/2. So we're going to take -1/2 times c. We have -2, 4, 5, -6, 11, and 8. And when we multiply each of those things by -1/2, you're just distributing to each one. So then you get 1. -1/2 times 4 is -2. -1/2 times 5 is -5/2. -1/2 times -6 is 3. -1/2 times 11 is -11/2. You can leave it as a reduced fraction, but it doesn't have to be simplified all the way. And then -1/2 times 8, we get -4. So there's the answer to our first problem. For the next one, we have 2b minus 4e. So since we're dealing with two different matrices, we need to look to make sure that the dimensions are the same. These are both rows by columns, 3 by 2 matrices. 3 rows and 2 columns. So this will be a two-part process. First of all, we need to take b and multiply it times 2. So let me go ahead and write down 2b. So each of these things times 2 will get 14, 0, -2, 8, -4, and 12. So there's 2b minus, we're going to take everything in e and multiply it by 4. So then we get -8, 20, 12, -40, -12, and 4. Then we just take each of the entries that is sitting in the same spot in the matrix and we subtract them. So 14 minus -8 is the same thing as 14 plus 8. So we'll get 22. 0 minus 12 is -12. And -2 minus a -12 is -2 plus 12, which is 10. 8 minus 20 is -12. -4 minus 40. -40 is -4 plus 40, so that's 36, and then 12 minus 4 is 8. So there's our answer there. For the next problem, we have 3b minus 2c. So comparing what I had before, 3b, so b is a 3 by 2 matrix, but c is a 2 by 3 matrix. They are not of the exact same dimensions. Therefore, this is not possible. And so that's what we'll write, not possible. Okay, for the next problem, -2 times a plus d. So I'm going to take a, multiply it times -2. So we get -10, 4, -2, and 8. So that's -2a, then plus d, and d is 0, 4, 3, and -2. These are both 2 by 2 matrices, so we can add them together. And we will get -10 plus 0 is -10, 4 plus 3 is 7, -2 plus 4 is 2, and 8 plus -2 is 6. Okay. On the next problem, the determinant of a. So remember, for the determinant, you have to have a square matrix, means same number of rows as columns. And so we take the first diagonal and multiply it together, and then we take the other diagonal and multiply it together, and we take the first diagonal minus the other. So 5 times -4 is -20, and then 2 times -2 times 1 is -2. So -20 minus a -2 is -18. Okay, and then for the last problem for this section, d to the -1, that means the inverse matrix of d. So the first thing we need to do is find the determinant. So just like we did a second ago, 0 times -2, so the determinant of d, okay, 0 times -2 is 0, minus 4 times 3 is 12, so that equals -12. It's not 0, so that means this will have an inverse. So the inverse matrix will be 1 over my determinant, which was -12, times, so remember when we do these, that we have this little flip-flop matrix, and so the first diagonal, those will switch places, but the other diagonal just gets multiplied by -1. So this will be -2 and 0, they switch places, and then -4 and -3. Now we just need to distribute this scalar here, get a scalar product of, so -1/12 times -2 is 1/6. -1/12 times -3 is 1/4. Just multiplying and reducing those fractions in the same step. -1/12 times -4 is 1/3. And then, of course, -1/12 times 0 is 0. And that is your inverse matrix. All right, for this next problem, describe the transformation from the parent function if f of x is the parent function, and g of x equals 3 times f of -x minus 2. So remember, we always do left and right first, then we look at multiplying the x's, then we look at multiplying the y values, and then last but not least, we go up or down. So we need to look, are we moving anything left and right? No, we're not, but multiplying the x's, there is something going on right here. So multiplying an x by -1 will reflect it across the y-axis. Next, are we multiplying the y values? Yes, we are, by 3. So that means we're going to do a vertical stretch by a factor of 3. Remember, it's a stretch if you're multiplying by a number bigger than 1, and it's a compression if you're multiplying by a number less than 1. And then finally, the last thing we look for is it up or down, and the number in the back tells us if we're moving it up or down, and so we're going to go down 2. And that's it. All right, number 8. Write the equation for the dashed figure if g of x is a transformation of the solid figure. So that means we're going from the solid figure to the dashed figure. And then that dashed figure, that's the equation we're writing as far as g of x. The solid figure was f of x. Okay, so looking at this graph, I can see that comparing the two parts, this part was 4 units long, this part was 4 units long. So it wasn't horizontally stretched or compressed. This part was 1, 2, 4 units tall. This is still 1, 2, 3, 4 units tall. So it wasn't vertically stretched or compressed either. I can also see that they're still both opening down. This little tent-like thing is still opening down. So it wasn't reflected over the x-axis, but the handle part here is going the opposite direction. So it was reflected across the y-axis. So I know it's been reflected across the y-axis. So if I use this little point as a reference, reflecting that across the y-axis won't move it, but then I can see that it went to the left 2, and then it went up 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not quite perfect, but we'll say that that's 9. Okay, so g of x is the function. Okay, so we know it got reflected across the y-axis, so here's what we should do. F of, okay, so first of all, we need to look at, did it move left and right? And this is where it gets a little tricky, because even though it seems like, okay, I went to the left 2 and up 9, you can't forget that there was a reflection there, and that when you write your function here, that left and right always goes first. So the way that we should think about this is, I know that after I go left and right, remember these steps up here, you go left, right, then you multiply the x's, which includes reflections. So if my goal is to get to this point here and then move it up 9, but I know I have to move it to the left and to the right, what I should first do is move it to the right, and then it gets reflected over the y-axis, and then it gets moved up 9. So I need to actually move it to the right 2. So that means we'll have a minus 2 right here. And then reflecting it across the y-axis, that's going to be a negative x. And then moving it up 9, that's plus 9. So check it again. Remember your order. So we go to the right 2. So there's 1, 2. Then reflect it over the y-axis. So that's over here. And then up 9. Be careful with those. Okay, for part B, again, I'm going from the solid one to the dashed one. Looking at it, I can see that it is of the same width, as this is 3 apart and this is 3 apart. This is about 2 tall for this little slant. That's still about 2 tall. And I can see that they open in opposite directions. So I know that it got reflected over the x-axis. And so if I used this point, reflecting it across the y-axis is down here, but I needed to get it over here. So we're going to reflect, and we also have it to the right 3. So g of x equals, so I know it's going to move to the right 3, so 1, 2, 3, and then reflecting it across the x-axis. So this means to the right 3, and then reflecting across the x-axis, we'll put a negative in the front. So you can always check. So if I picked this point to test it, I go to the right 3, 1, 2, 3, and then reflect, that is the correct corresponding point. Okay, write the equation for each function graph below using transformations of parent functions. It is your job to know the parent function for these two graphs, and these are both v's, so that means that they are absolute value functions. And so you would need to know that the parent function sits on the points 0, 0, and then 1, 1, and 2, 2, and then negative 1, 1, and negative 2, 2. So those are my parent points. Now that we've cleared that up, we're looking for how did this original gray function get to where the black one is. So it didn't move left and right, it didn't move up and down because the vertex did not move. But I can clearly see it got reflected over the x-axis, and this point became this one. So let's write down what we have so far. You could use f of x, you could use g of x, it doesn't matter. F of x equals, okay, I know that it got reflected over the x-axis, so there will be a negative in the front. So this one being reflected over will become a negative 1, but that y value is actually a negative 2. So I'm multiplying my y values by negative 2. This y value that was at positive 2 is now at negative 4. Then I have my absolute value symbols. I didn't move left or right, so I don't have to add or subtract anything, but my x value of 1 became an x value of 3, and my x value of 2 became an x value of 6. So I'm multiplying my x values by 3. That means when I write down my equation, I should have 1/3 x because you have the reciprocal. Okay, number 10. So again, looking at where my parent points were, so where they're going to be now. My vertex definitely moved over and down. The shape is generally the same. We're just going up one diagonal at a time, little slope of 1. So it didn't get stretched or compressed in any way, but it just got moved to the right, 1, 2, 3, and then down 1. So this function, say I call it g of x, it doesn't matter. But absolute value of, it didn't get multiplied, the x or the y. It went to the right, 1, 2, 3, so that's a minus 3. And then it also went down 1, so that's a minus 1. For the next section, we are going to graph each function by applying transformations to the parent points and then state the domain and range in interval notation. Okay, so for number 11, if you wanted to, you could put the parent points on your graph. Let's talk about what the transformations will be. So left and right, looks like we're going to the left 2. Then we're not multiplying x's, we're multiplying the y values, which are going to reflect over the x-axis. And then we're going to go up 1. So taking each of these points, we're going to go to the left 2, reflect over the x, up 1. To the left, oops, that is definitely not to the left. Let's try that again. to the left to reflect over the x, up 1, to the left to reflect over the x, up 1, to the left to reflect over the x, up 1, and then you could see the pattern at that point. My domain, don't forget these are in interval notation. My domain, this will keep going on forever, so in interval notation, it's all real numbers, like that. For the range, I know that it'll go down to negative infinity, but the highest y value that we'll get is 1, and we include that one because it's a closed point. Let's look at the next graph. So looking at our transformations, we're not going left and right, but we do have to multiply our x values by -2. That's going to do two things. The negative will reflect it over the y-axis, and the 2, we're actually multiplying by 1/2 right there, right? Not 2. So we're going to do a horizontal compression by 1/2. And then we look at multiplying the y values, and we have a vertical compression by 1/2. So it's going to be a really squished graph. Okay, so using our parent points, again, you have to know these. They will not be given to you. We're going to take each point, reflect it over the y-axis, multiply the x by 1/2, and then multiply the y by 1/2. So the vertex will stay in the same place. The next point, reflect over the y-axis, multiply the x by 1/2 and the y by 1/2. The next one, reflect over the y-axis, multiply the x by 1/2 and then the y by 1/2. The next point, reflect over the y-axis, multiply the x by 1/2 and the y by 1/2, and then the same thing for the other. So it's just a little tiny graph, and actually it's going to look like it's in the exact same spot, but I can see that my points have been squished in vertically and horizontally. It is compressed. So for the domain, my domain is the x values. It will keep going out to each side forever, so it's negative infinity to positive infinity. And then my range, my smallest y value is 0, and we include that because it's a closed point, and it goes up to positive infinity. All right, we have two more problems to do together. On this one, we can see that it will go to the right 3. It will, the negative in the front, reflect it over the x-axis. And then also the 2 will do a vertical stretch by a factor of 2. So my parent points were here. So I'm going to take each point, go to the right 3, reflect over the x, and multiply the y value by 2. So the vertex is right here. To the right, 1, 2, 3, reflect over the x times the y value by 2, and we're there. And then this one, if I go to the right, 1, 2, 3, reflect over the x times 2, then you can see the shape of what the absolute value function will look like. For the domain, my x values will go on forever, so it's negative infinity to positive infinity. And my range goes from negative infinity to 0. It's all the values less than 0. And then the last one, here, the x values, I'm not going left and right, but I am multiplying the x's by 3/2. And that is bigger than 1, so that's a horizontal stretch by a factor of 3/2. And then we're going to go down 3. So my parent points, I'm going to multiply each one by 1.5 and then go down 3. So 0 times its x value times 1.5, it's still 0, down 3. 1, 2, 3. 1 times 1.5, it's 1.5, and then go down 1, 2, 3. Same thing over here. Negative 1 times 3/2 is negative 1.5. And down 1, 2, 3. And then you can kind of see what your pattern will be. Here's your graph. Of course, if you need to do the others, you're more than welcome to. The domain will go from negative infinity to positive infinity, and the range, our smallest y value, is -3. We include it going up to positive infinity. Okay, that's the entire review sheet. If you have any questions, feel free to ask. a teacher, and don't forget to look over your enrichment as you may see some questions on your test, and good luck. Bye.